In this video, we are going to look at the angles of elevation and depression. So first, let's look at the angles of elevation. So here we have a man, and let's say he's looking forward. So we'll draw a horizontal line. And this horizontal line will represent his line of sight. So now we have this bird up here. So let's say he looks up at this bird. So now he changes his line of sight from horizontal to looking up at the bird. Now this angle formed here from looking horizontal and then looking up at the bird is called the angle of elevation. So again, we have a man that's looking horizontal, then he notices a bird, so then he looks up at the bird, and the angle formed from looking horizontal and then looking up is the angle of elevation. So now notice, in order to obtain the angle of elevation, it must be taken from the horizontal line. Now we want to look at something called the altitude of the sun, which is simply the angle of elevation of the sun. All right, so I'm going to write that the altitude of the sun is the angle of elevation of the sun. So again, we have our man, and then we have the sun up here. So the man will be looking horizontal first. And then if he looks up at the sun, this angle formed here would be the angle of elevation of the sun, which is called the altitude of the sun. All right, so if you ever get a question asking you to find what is the altitude of the sun, it's simply the angle of elevation of the sun. Now let's look at a situation. We have a building on horizontal ground, so the brown line is horizontal ground. We have the sun up in the sky here. Now we know light travels in straight lines. So I'll draw some straight lines coming from the sun, which will represent the rays of the sun. So I have some lines coming like this. It will hit the building. All right, so it wouldn't pass through the building. All right, so these lines, these rays hitting the building and not passing through the building. But then you're going to get this first ray of light that just passes the top of the building and makes it through. So now the other rays of light that makes it through, we're going to have light on the surface. So for all the rays of light that was blocked by the building, within here we're going to have a shadow, and then out here we're going to have light. So here I have this black line to represent the shadow. So from here to here we'll have the shadow, because in this portion the rays of light is being blocked by the building, and then this first ray of light passes through here, and then from here onwards these rays of light will pass through. So we have light on the surface here. All right, and then here would be the shadow. Now this would be the horizontal line here, and this ray of light going up at the sun would be the angle of elevation of the sun. Therefore, this angle within here would be the altitude of the sun. All right, so there we have it, the altitude of the sun, which is the angle of elevation of the sun. Horizontal line, line going up at the sun, forming this angle, which is the altitude of the sun. So here we have our first question, where a flagpole casts a shadow of 8 meters when the altitude of the sun is 30 degrees. What is the height of the flagpole? So first, I'll draw the horizontal ground. I would let a vertical line represent the flagpole. I'll have the sun up in the sky here, and I'll have a ray of light coming from the sun that's crossing the top of the flagpole. And now the altitude of the sun is 30 degrees, so that's the angle of elevation of the sun. So from the horizontal line going up, that angle formed would be the angle of elevation. So that would be 30 degrees here. Now, seeing that this is horizontal ground and our flagpole is assumed to be vertical, it will form a 90-degree angle right here. Now we are saying that the flagpole casts a shadow of 8 meters. So remember, the first ray of light that crosses the top of the flagpole will be here. So after this would be light all here. And from here to here would be a shadow. So we have our shadow here. And this shadow is 8 meters long. So what we have here is a right angle triangle, with this side being 8 meters, this angle being 30 degrees. And what we want to do is find the height of the flagpole. So here would be H. So I just drew a right angle triangle here. We're going to put in the sides H for the height of the flagpole and 8 meters here. We're going to put in the 30 degrees. It's a right angle triangle. We have one side, we have an angle, and we're going to find this missing side. So we're going to use our trig ratios. So we know that the side opposite the right angle is your hypotenuse. If you draw a line from the right angle, we'll touch the hypotenuse. So this is the hypotenuse here. The 30 degrees is the angle that's given, so opposite to that will be the opposite side. So the height of the flagpole is the opposite side, and the remaining side is the adjacent side. We say soka toi. Well, first of all, we want to find the opposite side, so our trig ratio must have opposite in it. And then the other side that's given is adjacent. So we're looking for the trig ratio with opposite and adjacent. So we say soka toi, which one has O and A, and that will be toi. I'll just write it out here. Soka toi. All right, we're looking for the ratio with opposite and adjacent. So O and H. What we're looking for is O and A. A and H, no, we can't use that. And toi, O and A, opposite and adjacent. Right? So that's why we're using tan. So we're going to write tan theta is equal to opposite over adjacent. Our angle is 30 degrees. So we're going to have tan 30 degrees is equal to the opposite, which is H, over the adjacent, which is 8. We're going to put this tan 30 over 1 so we can cross multiply. So we have tan 30 degrees over 1 is equal to H over 8. So now when we multiply 1 by H, we're going to get H. And when we multiply tan 30 by 8, we get 8 times tan 30, which is 8 tan 30 degrees. So we just have to go to our calculator and type in 8 tan 30. Make sure the calculator is on degrees. So I'll write H is equal to, all right, so I have my calculator up. It's on degrees. Well, if you can see this D on the top here, it's on degrees. So let's type in 8 tan 30, press equal. Let's change this to decimal. And I got 4.618. I'll just write this to 3 significant figures. So 4.61, stop here. After it's an 8. So this one will go up by 1, and I get 4.62. So height is 4.62 meters. All right, and this would be your answer, the height of the flagpole. So for my second question, dealing with angles of elevation, we have a point is 50 meters away from the base of a building. If the building is 30 meters tall, what is the angle of elevation from the point to the top of the building? So first I'll draw a horizontal line to represent the ground. Then I'll draw my building here, going up vertical. And of course, it will form a 90-degree angle with the horizontal ground. Then I'll have my point, which is 50 meters away from the base of the building. All right, so I'll label the distance from the point to the building, the base of the building, as 50 meters. And then we know that the height of the building is 30 meters tall. All right, so I'll just label the height of the building here being 30 meters tall. So now what we want is the angle of elevation from the point to the top of the building. So now notice the point is on horizontal ground, and then going up to the top of the building, we see horizontal, then going up. So that's the angle of elevation. So if I draw that line going up to the top of the building, this here will be the angle of elevation that we are looking for. All right, horizontal, then going up to the top of the building. So that's the angle of elevation from the point to the top of the building. So again, this is a right angle triangle where we have the length of the base here as 50 meters and the height here as 30 meters. And we want to find this angle of elevation here. So as you know, we're going to label the sides of this right angle triangle. So opposite the right angle is the hypotenuse. Opposite the angle that we want to find, which is the angle of elevation, E, will be the opposite side. and the remaining side will be the adjacent side. So now we look at the two sides that we are given, which is the opposite and the adjacent. And we say so, ka, toi. And we see which one has opposite and adjacent. And again, that's tan, opposite and adjacent. So you're going to write tan theta is equal to the opposite side over the adjacent side. So now we're going to have tan E, because that's the angle of elevation, is equal to the opposite, which is theta, over the adjacent, which is 50 meters. So now the angle of elevation will be the tan inverse of theta over 50. So the angle of elevation would be. So now we'll pull up our scientific calculator to work this out. So on this calculator, we have to press shift first, then tan. Now you see tan inverse comes up. On other calculators, you have to press second function first. It doesn't have a shift button, it's second function. So you press second function, then tan, and the tan inverse will come up. Now on this calculator, the brackets open one time. If your calculator didn't open brackets one time, you'll have to open brackets. And then you're going to put 30 divided by 50, and then close the brackets and press equal. And we get 30.96. So writing this to three significant figures, that's 30.9. We stop at the 9. After the 9 is a 6, so this 9 goes up by 1, which will carry this 0 up by 1. So we just have 31 degrees. So my angle of elevation would be 31 degrees to three significant figures. So now let's look at the angles of depression. So again, I have a man and I have a bird up in the sky. And let's say this time that the bird is looking horizontal. So I just label this my horizontal line. And then the bird looks down at the man. Now this angle formed here from looking horizontal and then looking down will be the angle of depression. So the angle of depression is looking horizontal and then looking down. And the angle of elevation is looking horizontal and then looking up. So that's the difference there. So here we have my first question for the angles of depression. So we have two buildings are 70 meters apart. So I have my two buildings here, 70 meters apart, and have heights 30 meters and 50 meters respectively. So the height of this building is 30 meters and the height of this building is 50 meters. What is the angle of depression from the top of the taller building? So from the time I say what is the angle of depression from the top of the taller building, I have to draw a horizontal line from the top of the taller building. So that is, what is the angle of depression from the top of the taller building to the top of the shorter building? So from the top of the taller building to the top of the shorter building. So therefore this line will come down like this now to the top of the shorter building. And this angle within here would be my angle of depression. Now the question will be now how to find this angle of depression. Now we're going to use trig ratios and we need a right angle triangle to do that. So what I could do is bring a vertical line up from this point straight up here, and this will form a right angle with the horizontal line. And the distance of this vertical line will be, if here is 30 and then here is 50, if we take away 30 from 50, we get 20. So the length of this vertical line here will be 20 meters. So now we have a right angle triangle where we know the length of this side is 20. And of course, this length of this side here will be same as the 70 meters here. So what I'll do is draw this right angle triangle. We'll have the length of this side here being 70 meters and the length of this side being 20 meters. And I'll call this angle D, which is the angle of depression. So now that we have our right angle triangle, let's label the sides of this right angle triangle. So the side opposite the right angle is the hypotenuse. The side opposite the angle that we want to find is the opposite side, and the angle that we want to find is this D, the angle of depression. So this 20 meters is the opposite side, and the remaining side will be the adjacent side. So again, we say soka toi. We have the opposite side and we have the adjacent side. So our ratio must have opposite and adjacent. And if we say soka toi, we know that is tan. Tan is equal to opposite over adjacent. So we're going to have tan theta is equal to the opposite side over the adjacent side. So that will be tan, my angle of depression is D, right? So that's your theta. And the opposite side is 20. And the adjacent side is 70. So now the angle of depression is equal to a tan inverse of 20 over 70. So let's go to our calculator. And I'll press Shift, then tan. Calculator open brackets for me automatically. So then I'll type in 20 divided by 70 and close brackets. Press equal, and I get 15.94. So to three significant figures, that's 15.9. Stop there. After the 9 is a 4, so this 9 remains the same. So that's 15.9 degrees. All right, so my angle of depression is equal to 15.9 degrees. And that will bring us to the end of this video.